So let's take chlorobenzene. Chlorine has 6 electrons in total. So what's going to happen is chlorine is going to use 1 electron to form a double bond with this carbon, and it's going to give away completely its other electron. Okay, so this arrow shifting is not just shifting of 1 electron, it's shifting of 2 electrons. And the electron completely gave it way to this carbon. This carbon is going to give to this carbon. So this double bond shifts like this. Okay. So what's happening is a double bond is formed because, as I told you, this chlorine is going to utilize one of its electron to form a double bond. And it completely gave away its other electron, remember? So it's going to attain a plus charge. So an atom attains a positive charge only when it has completely given away an electron. When it's participating in a covalent bond, it doesn't get a plus charge. If it has completely given away its electron, that's when it gets the plus charge. So again, this got shifted this side, so here you got a minus. So where did this electron come from? This electron came from chlorine. Remember, chlorine gave away 2 electrons. It completely gave away 1 electron, and the other electron it used to form a covalent bond. It's sharing with this carbon, right? So this is what we get, and this electron is the electron which we got from chlorine. So in the next step, like we are familiar, let's do something. We'll write this double bond as plus and minus. Okay. Plus. So you may ask me, why should we write this double bond as plus and minus? Why can't I write it as plus and why can I write as plus minus? Why can't 2 negative charges be side by side to each other? It's generally unstable in a benzene compound or any compound for 2 like charges to be placed side by side. That's unstable. What's unstable does not generally occur, so it does not happen. Even this step, no textbook will show you this step. I'm just writing this step for understanding purposes. So what happens here is you get the same thing, double bond. You get this, and we have this here a double bond gets formed. Here a double bond was there from before, and we have a minus charge here. So these are resonance structures of chlorobenzene. These are called resonance structures of chlorobenzene. So what happens now? Okay, how do we show this? We show this like this. Like this. I'll show this like this. Like this electron is traveling to here. Okay, so this is how it works. Now what happens? This electron travels here. How do we show it? Again, let's write plus minus, and we'll split this double bond and write it as plus and minus. And plus charge will be the neighbor of this minus charge. Why? Because 2 like charges placed next to each other is unstable. So we have minus, and I write plus here, minus. So I split this double bond into plus and minus. Then we have this double bond plus. Okay, so this is how it works. Here we have a plus. And then what happens is, again, here a double bond gets formed. Again, this is something which you don't write normally when you are writing the resonance structures. Like, this doesn't count as a resonance structure. This doesn't count as a resonance structure. This one counts as 1. This one counts as 1. So here what do we write? Again, we have this. We have a double bond here. You have a minus here. Okay. So in the next step, what happens is this electron, which came from chlorine in the first place, again goes there. Like, it shifts to chlorine again. So this electron is going back to chlorine. So when it goes back to chlorine, what happens? We ended up in the same place, right? Where it was before. Like, we got chlorobenzene again. But this and this structure are not one and the same. Why? Because if I name this carbon 1, 2, 3, 4, 5, 6, then here there was a double bond between first carbon and second carbon. But here there's a double bond between first carbon and, which carbon is this? 1, 2, 3, 4, 5, 6. Yeah, sixth carbon. So it's not equivalent, right? Having a double bond between first and sixth carbon and first and second carbon. So these two are two different structures. Okay. So these two are two different structures. So if I ask you, how many different structures can chlorobenzene take? 1, 2, 3, 4, 5. So it coexists in all these states. 1, 2, we have 3, 4, 5. It coexists in all these states, but most of the time it exists as 1 and 5, but it does coexist in all the states. This is called resonance. What's resonance? Resonance is the phenomenon in which a molecule occurs in more than one state. So this molecule keeps varying between all these states. Like 1 minute this is this, the other minute it's in the second form, the other minute it's in the third form, fourth, fifth, but most of the time it's in first and fifth form. So no one actually knew that it could even exhibit 2, 3, 4 until many years. Okay, they've later realized, but they thought that it only exhibited first form. Why? Because it's more, in most of the cases it's in first and fifth form. These forms come up real less. While it keeps changing, these forms come up real less. So what happened? Let's go through it again. So chlorine had 6 electrons in total. So it this arrow doesn't represent movement of 1 electron. It represents movement of 2 electrons. So of that, 1 electron is being used to form a covalent bond between this first carbon and chlorine. Okay. So 1 electron is being shared and the other electron is completely transferred to this carbon. And this completely transferred electron to this carbon transferred to the second carbon. So chlorine transferred one of its electron completely to first carbon, and the first carbon transferred that electron to second carbon. So here we got a double bond because 1 electron chlorine formed a double bond with this carbon, and then the electron missing from here, it's here. So chlorine attained plus charge because it completely gave away electron, not because of the formation of double bond with this carbon. So that electron that chlorine completely gave away, it's here. Okay. So now this electron shifts here. This electron shifts here. This electron shifts here. And we have written like how the shifting is actually taking place. We just wrote this intermediate structure. This doesn't actually exist. This is just for explanation purposes. So this electron keeps oscillating in the benzene ring. So it goes here. And from here, the electron goes here. Like this carbon starts giving electron to this carbon. So what happened is we have 1, 2, 3, 4, 5. So the second carbon gave its electron to fourth carbon, and then the fourth carbon gave its electron to sixth carbon, right? And after that, what happened? This electron went back to its owner, Cl, and we got 5. So chlorobenzene coexists in these 5 states. Chlorobenzene coexists in these 5 states, but most of the time it's in 1 and 5. Okay.